Students, let's start the redox reaction. So, what is redox reaction? Okay, redox reaction, the word redox, it is formed from the two different words, that is reduction and oxidation. So, in your previous classes also, you have studied about the redox reaction, where you have studied about the phenomena of oxidation reaction and the reduction reaction, which generally occur simultaneously in a single reaction, chemical reaction only. If oxidation is occurring out, then there will be reduction also in that particular reaction. Okay, so hence both are vice versa to each. So what is oxidation reaction and what is reduction reaction? In the previous classes we have studied that oxidation is the addition of oxygen, while reduction is the removal of oxygen and addition of hydrogen. Okay, or in other words we can say that removal of hydrogen and addition of oxygen is oxidation, and removal of oxygen and addition of hydrogen is reduction. Okay, but now we will consider the oxidation reaction on the basis of the losing of electrons. Okay, so on the basis of this, if we are going to define the oxidation reaction, then it will be a chemical process in which one or more electrons are lost by an atom. Okay, and a chemical process in which one or more electrons lost by an atom is called oxidation. Okay, in other words, if we consider that in the oxidation process the electron is losing, it means that the increase in the increase in oxidation state will be observed. The increase in oxidation state will be observed here. Okay, a chemical process in which one or more electrons are lost by an atom, it is called oxidation process, and their increase in the oxidation state will be observed there. Well, then what is reduction? What will be the definition for reduction? Then the reduction's definition become a chemical process in which one or more electrons are gained by an atom is called reduction. Okay, it is termed as reduction. So the decrease in oxidation state will be observed in reduction. Okay, a decrease in oxidation state will be observed here in the case of reduction. Okay, so both this process, that is chemical process of oxidation and chemical process of reduction, in both the cases we are going to observe this, that the increase in oxidation state will be there, then it will be termed as oxidation, and decrease in oxidation state if we are observing, then it will be reduction there. So here let's see for some example in order to understand this thing. So here Na, let's take Na, sodium solid. So if sodium atom is losing one electron, okay, so here the oxidation state of the sodium will increase. So it means that it is an oxidation process. It is an oxidation process. And simultaneously, the electrons lost by oxygen, it is gained up by the electron lost by sodium, it is gained up by oxygen atom to form oxygen's 2 minus ion. Okay, so here the formation of oxygen 2 minus ion, here we are observing that the oxidation number which was 0 for O2, it has been decreased from 0 to minus 2. Okay, so it means that reduction in the atom's oxidation state is been seen out here. So therefore this will be the reduction process here. Okay, this will be the reduction process. So the reaction which is showing the oxidation process, it is termed as oxidation half cycle, half reaction, and the reaction which is showing the reduction part of the reaction, it is termed as reduction half cycle. Okay, so in order to summate these both reactions, what we will do, we will multiply 4 in the oxidation part of the reaction. Okay, then the 4 electrons can be easily cancelled up here, and the left out compounds which will be formed out here, it will be 4Na plus O2 gas will give 2 Na2 plus Na plus 2 O2 minus, or we can simply write it as 2NaO. Okay, 2NO can be written as. So this is the total redox reaction. This is a total redox reaction which is summated by the two half reactions. One is the oxidation half reaction and one is the reduction half reaction. Okay, so this is a redox reactions example in which oxidation and reduction has been taken place. Similarly, some more examples for the reduction of for the reduction and oxidation in a aqueous solution. Okay, how to see, how to observe the redox reaction in an aqueous solution. What kind of behavior it has been? AQUEOUS, 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 aqueous solution. So what kind of reaction will be seen out here? Here, zinc solid plus copper in the aqueous solution will give zinc aqueous plus copper solution. So here you can see that the oxidation state for zinc is being increased out here. So it means the oxidation of zinc has been carried out here, while the oxidation state for copper has been decreased. So it means that reduction has been done in is been occurred in the case of the copper here. So here also a redox reaction is been taken place, but here the formation of ions has been taking place. No compound formation has been taking place in the case of the aqueous solution. So this is the redox reaction. Okay. So here we can say that as copper is oxidizing zinc here, so it will be termed as oxidizing agent. Copper will be termed as what? It will be termed as oxidizing agent. While the zinc is reducing the copper, so it will be termed as an reducing agent. It will be termed as reducing agent. Okay. So for remembering this process that oxidation is losing and reduction is gaining, we can make a trick that we can simply use the word oil rig. Okay, oil rig means what? Oil rig means the process, the particular machine which helps in the extraction of the oil from the earth. Okay, so that machine is termed as oil rig. Okay, so here OILRIG, oil rig. Just simply remember this word oil rig. So here O means oxidation, I means is, and L means losing. So it means that oxidation is losing of electrons. Okay, oxidation is losing of electrons, while R is reduction, I is and G is for gaining. So here it will be reduction is gaining of electrons. Or oxidation is losing of electrons. Reduction is gaining of electrons. Okay. So this will be the oil rig. Okay. By using this particular word, you can simply make that oxidation is losing and reduction is gaining. Reduction is gaining. Okay. So here we can also conclude that the substance which is oxidizing, it is a good reducing agent, and a substance which is reducing, it is oxidizing agent. Okay. So let's identify using some reactions. Let's identify the species which are undergoing oxidation or reduction. Undergoing oxidation and reduction. Okay. So here H2S gas reacting with chlorine gas to produce 2HCl gas plus sulfur solid. Okay. So here which is oxidizing and which is reducing. So let's see. For that we have to find out the oxidation state for each of the element on the both the sides. So here hydrogen is combined with sulfur. So sulfur is having the oxidation state of -2 while hydrogen is having the oxidation state of +1. Okay. Here chlorine is having oxidation state of 0 because when diatomic molecules are formed, then they are having oxidation state 0. Here hydrogen is having +1 and chlorine is having oxidation state of -1, while sulfur is alone here, so it will be having 0 charge, that is 0 oxidation state here. So on comparing here, we will see that hydrogen's oxidation state is still +1 on both the sides. So it means that hydrogen has not even undergone reduction, not the oxidation here. Okay. So let's see for the sulfur. So for sulfur, we can observe that the oxidation state for sulfur from -2 it has become 0. So it means that increase in the oxidation state has been observed out here. So it means that it is the oxidation here for sulfur. While in the case of chlorine, from 0, the oxidation state of chlorine has become -1. So it means that reduction in the reduction in the oxidation state has been observed out here. So it means that it is reduction reaction here. Okay, the sulfur the chlorine has been reduced out here. Okay, so hence we have identified that sulfur is oxidizing here and chlorine is reducing here. Similarly, for the next reaction, let's find out that which of the substance is oxidizing and which of the substance is reducing here. So 3FeO4 is reacting with 8 aluminium atoms to form ferrous and 4Al2O3. Okay, so here let's find out the oxidation states here. So for oxygen it will be -2, for sulfur it will be +2. For oxygen it will be -2 and for sulfur it will be for oxygen it will be -2 and for iron it will be +2. For aluminium, as it is not as it is alone here, so it will be having oxidation state of 0. Here iron is alone, it means it will be having an oxidation state of 0. Then Al2O3, here oxidation state will be for oxygen it will be -2 and for aluminium it will be +3. Okay, so now let's observe what is the where is the oxidation is been gone and where the reduction has been taken place here. So here we can observe that in the case of iron, the oxidation has been reduced from +2 to 0. So it means that iron has been reduced here. So the reduction process has been taken for the iron case. And in the case of aluminium, we can observe that the increase in the oxidation state from 0, the oxidation state has increased to +3. So it means that here oxidation process has been taken. Okay. So iron has been reduced here to form iron solid, and aluminium solid has been oxidized here to form aluminium oxide here. While the oxidation state is -2 only in both the cases. So oxidation has neither undergone oxidation nor the reduction reaction. Okay. So like this only we have to identify the oxidation reaction or the reduction reaction. Now let's find out the oxidation state of the different atoms which are present. Okay, so for this rules are there. Okay, we have to follow the rules for determination of oxidation number of an atom. Oxidation number of an atom. Okay, so number one, the oxidation number for an atom in the free or elementary state, in free or elementary state, is 0. Okay, so oxidation number for atoms in any free state or elementary state or in any allotropic state, okay, in any allotropic state is considered to be 0. The oxidation number of an element in a single ion, okay, in a single ion, that is monoatomic ion, is same as the charge on the ion, is same as the charge on ion. Okay, so for example, Al3 plus is there. Okay, so the oxidation state it will be +3 only. Okay, here it will be +3. The oxidation state here it will be +3. If O2 minus is there, so the oxidation state there will be -2. Okay, so hence for the ions, the charge they are possessing, that will be their oxidation state. Okay, next, in binary compounds, in binary compounds of metals and non-metals, of metals and non-metals, the oxidation number for metals is always positive, and for non-metals is always negative. Okay, for non-metals it will be always negative, and for metals it will be always positive there in the case of binary compounds of metals and non-metals. Next, rule number 4. In compounds formed by the combination of non-metallic atoms, in the compounds formed by combination of non-metallic atoms, non-metallic atoms, the atoms with higher electronegativity, higher electronegativity is given negative oxidation state. Negative oxidation state. Okay. So for example, in HCl, if we are considering, both are non-metals, hydrogen and chlorine both are non-metals. So here chlorine is highly electronegative as comparison to that of the hydrogen. So we will say that chlorine is having minus charge while oxygen is having plus charge. Okay, the chlorine will be having a negative oxidation state while the hydrogen will be having positive oxidation state here, because it is more electropositive as comparison to that of the chlorine here. Next, in all compounds, in all compounds, hydrogen is plus 1 except in hydrides, except in hydrides of active metals LiH, NaH, KH, MgH, etc., MgH2, etc. Okay, in this case only we will see that the hydrogen is having minus 1 oxidation state. Okay, it is having minus 1 oxidation state, while in all the cases other than these hydrides we will see that they are having, the oxygen is having plus 1 oxidation state. The oxidation number for oxygen is minus 2 in nearly all compounds. Okay, in most of compounds we will see that it is minus 2. However, but in peroxides it is minus 1, and in superoxides it will be minus 1. Okay, and in the superoxides it will be, and in superoxides it is minus 1 by 2. Okay, this is an exceptional case for the oxygen, that generally it is having plus 1 minus 2 charge but oxidation state, but in the case of peroxides we will be observing that it is having minus 1 oxidation state, and in the case of superoxide it is having minus 1 by 2 oxidation state. The next seventh rule is that the most electronegative element, fluorine, has oxidation number of minus 1, but when fluorine is bonded to oxygen or other halogens, it can show oxidation state of plus 5 in IF5, in IF7 it can show plus 7. Okay, so like this the oxidation state of fluorine can also be different in rare conditions when it is forming a bond with other halogens, or with oxygen it is forming the bond there. For neutral molecules, the sum of oxidation state, the sum of oxidation state of all atoms in, sorry, is equal to 0. It is equal to 0. Okay. So this is the um, rules which we have to follow in order to finding out the oxidation state. So let's find out oxidation states for some of the compounds. So first take H2SO3. Here we have to find out the oxidation state for sulfur. Okay, so let us take the oxidation state for sulfur is equals to X. We know that hydrogen must be +1 here and oxygen must be -2 here always. So here the total charge on this compound is 0. Okay, the resultant charge on this compound is 0. Then the calculation of X can be done by this formula: 2 into 1 plus X plus 3 into -2 is equals to 0. So on solving this equation, we will be able to find out the value of X2 plus X minus 6 is equals to 0. So the answer will be X minus 4 is equals to 0. So the value for X is +4 here. Okay, it is +4 here. It means that the oxidation state for sulfur here is +4. Now let's find the oxidation state for sulfur in H2O4 2 minus. Okay, so this is a compound, this is a molecule where sulfur and oxygen are one combined with each other, but this compound is having a charge of -2 here. So here we have to find out the oxidation state for sulfur. Okay, so let's take sulfur's oxidation state is equals to X. Oxygen's oxidation state will be naturally -2 here. Okay, so on calculating here, we have to calculate the value for sulfur's oxidation state. So 2x, 2 sulfur, the atomicity of sulfur here is 2 and the atomicity of oxygen here is 4. So here 2x will be there and 4 will be multiplied with the -2 and the total charge on the substance is -2. Okay, so it will be is equals to -2 here. So 2x minus 8 is equals to -2. So the answer will become 2x is equals to 8 minus 2. X is equals to 6 by 2, that is equals to 3. So the answer will be +3. Okay, it will be +3. So like this we have to calculate the oxidation state for the different atoms. Okay, different molecules which are given out here. Okay, so I am giving you some of the homework questions for by using this particular method which I have demonstrated here. So for that, first is the first homework question for finding out the oxidation state. Find oxidation state of sulfur in Na2S2O3. Okay, in H2O7 2 minus, in H2SO4. So this is 1, 2, 3. This is for sulfur only. Okay, this question is for sulfur. Next, calculate oxidation state for the underlying atom. Okay, the underlined atom, for the underlined atom. For the underlined atom, it will be ClO3 minus. Chlorine will be there. Okay, for chlorine just calculate here. CH4 for carbon calculate here. Na2B4O7. Na2B4O7. For boron, calculate here. Na4FeCN6. For iron, calculate here. Okay. So here four more questions I have given you. You have to find out the oxidation state for the underlined atoms here. Okay, by using the method which I have demonstrated you. Okay. So for today, I am ending the class here only. In the next class, we are going to see the next topic for this chapter. That is the balancing of the redox reaction. Okay, there are before that we are going to see the types of redox reaction, and after that we are going to demonstrate we are going to see the balancing of the redox reaction by two different methods. Okay, so for today, thank you. We will meet up in the next class.